in more detail, but what this is looking at a line of best fit. Like we draw a line through here, and what sort of would that line mean? So Excel will do that for me. So click on the dot and the plus sign. I'm going to choose a trend line. Now it defaults to a straight line. We do want a straight line. Okay. Good to pay attention right now. Just want your name called out again. All right. More options. I want to read the equation of this line. So if you can't see, once you go to more options, this is where most of the options are underneath those, the little bar graph section here. This will tell me the intercept, what it started at, but I don't want to do that. I want to see the equation and maybe the R squared value if you want to use that for later on, but I'll just turn it off for now. There's my equation. It's a bit hard to see here, so I'm going to move that across and I'm going to make it a bit bigger using normal Excel home tools. Okay, Excel will default to pretty small fonts, so feel free to up the font in some of the headings and the titles. Now, for Trendline, the slope number, or the number in front of X, describes change or describes the rate of mercury per year that on average birds might get. Now I'm going to write increase in this question. It is increase. The number at the end, Canab, what does that tell me? What's the 0.898 sort of mean in an equation like this? I think Canab said the y-intercept. Excellent, excellent. All right. So this means that this line, if I drew it all the way through here, would click at 0.8. Now, that gives me an obvious error with the data. Or is it an error in the data? Because I do believe that means when that seagull was age 0, that it has a little bit of mercury in it. Is this possible? It certainly hasn't gone out to the garbage dump and found it itself because it's still in an egg. Is it possible that it may start with a little bit of mercury? So the class says yes, because it may. Inherit some from the blood of its mother. Yes, because it's like made from inside the mother. Yeah. So we've had a little discussion about that. So you would have to explain that a little bit, okay? Now I'm just going to let my sentences drift off a little bit so you're not just copying them all, okay? Exposure to mercury. All right, so far, just to wrap up, this is probably the end of our first little section. I have done age versus mercury. The data set that I used was all birds. Okay, so I'd be interested in if you did it for males versus mercury, females, age versus mercury, all birds, age versus mercury. I'm interested to see these numbers. Are these numbers the same? Or is one graph steeper than the other? Or is one like a moderate and is one of the other ones a strong correlation? Okay, people got a bit of an idea where we're heading. We're going to talk about a couple of other bits and pieces in the next video. So just flick back to this example. Here we have the mercury levels. So you should really say age versus mercury. That's the classic title for one of these graphs. All right, age versus mercury for female. Now, if it was me, I would say that this is a strong correlation. This is pretty strong as well, but it has a couple of outliers. But one thing's for sure, does this graph here look a little bit steeper than that graph? It's hard to tell because the units are slightly different. So what I need to show for the people, see here the 5, 10 to 15, and over here we have, okay? It's probably time that I should tell you, I think these graphs are not quite right. I think the person has got these two numbers the wrong way around. Anyway, not sure. But yeah, this is steeper. So the males would, in this shows the males would get mercury at a higher rate. So I'm not sure if your data is the same as that data. Don't think it is. Okay, there's our little symbol for micrograms, right? So in the book, insert symbol, U for micro. That giving people a bit of an idea of what's expected from this section. Only come back and talk extrapolation, interpolation. Okay, thank you.